So, welcome to this Tech Hour, which is on tools that do things with LaTeX source files besides turn them into PDF. So if we've got a LaTeX source file, of course we can turn it into PDF, but we might want to do other things as well. In particular, we might want to edit it, or we might want to understand it, or count the number of words in it, or we might want to search it. We might want to search it for something. So there's lots of things we can do with LaTeX source files that are not the same as creating PDF. Creating PDF is just one of the things we can do. And the good starting point is to see what happens with other computer languages. Now, computer languages are mostly for programming, but LaTeX source documents are for writing. So on the one hand, we've got languages like Python and C, which are programming language primarily. And then we've also got languages such as XML and LaTeX, which are all for writing documents. Now, XML has got a sort of well-defined document structure because there's a standard behind it, and there are tools for parsing XML documents into an abstract syntax tree and then doing things with them. Whereas for LaTeX, there are no such tools, or rather they're somewhat ad hoc because LaTeX syntax isn't exactly defined. And that's something that any tool that handles LaTeX source files has to finesse in some way. Another application for this, which is quite interesting, is there are tools such as Pandoc that create LaTeX. So Pandoc, if you want to create PDF from a document that's been input into Pandoc, very often the output you get will be LaTeX, and then you're asked to typeset it. Well, if you're puzzled as to what's going on, or you want to know how your input document relates to the output document, you rather like various information to go into the LaTeX document. So a tool that, so to speak, takes the LaTeX that Pandoc generates it and make it more palatable for the human is also useful. And for the tech old timers, the web system generates Pascal code, and the Pascal code has, so to speak, hints and comments in it that help you understand what's going on if you ever need to debug the thing. So these are a sort of range of examples where it might be useful. Another example where this sort of thing might be useful is if you're preparing documentation to go online. Now, most programming languages have keywords, and we know what to do with keywords, and we know what the keywords are because they're baked into the programming language at a pretty deep level. Whereas LaTeX is lots and lots of commands, some of which are simply the names of mathematical symbols, and some of which have different functions. So I thought it would be nice if you could upload or paste in a LaTeX document or a snippet of LaTeX and get a HTML-based view of how LaTeX understands what you've put in. So these are the matching delimiters. This is the numerator of a fraction. This is the denominator of the fraction. Those sorts of things. And I think that might be quite helpful for beginners who are faced with a piece of LaTeX they don't understand. They know that it gives the right output, or they found the output they want and they come across, got the source, and then they want to know how the various commands work and maybe features about the commands. So being able to parse the document and say, okay, this is \frac, we need to put in a link or a tooltip hint as to what frac does. And similarly, if you've got a wide range of examples of what LaTeX does, and somebody says, I want to know about frac, you can say, well, here are some snippets of mathematics that use frac. One of them might be helpful to you. So these are all ranges of examples of things that can be done with, besides typesetting LaTeX documents or LaTeX mathematics. Now, I've done a bit of research, and there are a lot of LaTeX editing tools that are JavaScript based. And I reckon that there's probably very little commonality in the way in which they use LaTeX. And I think that's a bit of a shame. First of all, because it's repeated effort. Secondly, because it leads to inconsistency and makes it harder for people to use things. Reusable parts, well designed, are very useful. A reusable component is expensive to produce, but valuable in use. And the final thing is, providing good components develops a community of practice. So if we go way back to Unix and, for example, the C programming language, I think one of the great things that happened about that was this little book called the C programming language, Carnegie and Ritchie. And people would learn that book, and they would learn not only the language fundamentals, but some of the things about thinking about C in C and those sorts of things. And that developed a community of practice. So there's all sorts of reasons why these tools are useful. I work in Python, and a talented Python programmer has created a tool called Black. It's, so to speak, named after Henry Ford, who said of the Model T, you could have it in any color you want as long as it's black. It's an opinionated formatter that simply formats the thing the right way, and a lot of projects are adopting it because it simply introduces a useful format consistency, and it means that you don't have to worry about how to format things when you're typing the code, because as part of the check-in process or the workflow, Black goes in and does the formatting for you. So you can think of Black as a sort of typesetter that produces text output rather than PDF output. And it sort of normalizes everything. So one of the great things about PDF output is that all the articles in the journal are printed as PDF and use the same styles. And so there's uniformity of the output that's quite helpful for the user. I think that uniformity of output makes the reader's job easier. So another area in which a normalizer, if you like, for LaTeX will be useful is where you have a group of people who have got shared responsibilities for a stream of documents. That might be technical typist, a typing pool, a publishing system. All those are various examples. And there's also the question of accessibility, which is that if you've got a formatter for tech documents and somebody is blind or visually impaired and they want to be a LaTeX author, then the formatting can be adapted to suit that. So in Python, I use on a blind math list, blind coders list, and Python uses indentation, and Python practices to put 4 spaces for each indent. And that's a disaster if you're a Braille user, or even if you're a screen reader user, because that's 4 characters gone. So the thing that everybody disapproves of in the Python community, which is to use tabs for indents, is actually absolutely the right thing to do if you're blind, because you can put your finger, you can, so to speak, scroll through the document, and the first character will tell you exactly what's going on, that it's an indent. And then the next character will tell you it's another indent. So this flexibility that makes accessibility is also another area in which this sort of tool will be useful. Now, I've got to step back a bit and say, well, Jonathan, you've got all these brilliant ideas, but don't reinvent the wheel. What's the state of the art on all of this? And I have to say that I haven't investigated it thoroughly, or even half thoroughly, and that must be one of the early tasks. There's a program called LaTeX, well, Tech Check, which exists. I think it's a bit old in the tooth, and Nelson knows more about it. I had a quick look at it here. One of the features is that it has a capability of wildcard file name extensions for the Amiga. So it seems as though it's a bit old in the tooth. And it's written in C, which is a high performance language, which many users, so to speak, lack the skills to use. So there's questions there. But certainly before going deeply into this, one has to say, well, what is there out there? What are the goals? And understand the land to do a reconnaissance before committing any resources. So I've sort of got a number of headings. The one is what happens in other languages. The second is LaTeX user experience. I think the focus on user experience, particularly beginner experience, is very important. The third is community of practice. The fourth is simple goals. So in agile programming, there's something called the minimal viable product. What's the smallest thing we can do that's useful? And it's not because our ambitions are limited. It's that we want to get feedback from users early. Somebody told me you're best off when you get your bad news early. In fact, you're also best off when you get your good news early. And the minimal viable product allows you to get news, information about how your piece of software fits into the world early. So one of the useful minimal viable products, I think, would be a LaTeX tokenizer. It simply turns it into tokens. In terms of the tech bulk, how tech reads what you type. I think that is already useful, and it provides a layer. In classical terms, you have LEX, which breaks the input into tokens. Already LEX or tokenizing is useful because it can, so to speak, see if the begins and the ends match. That sort of thing is fairly easy to build on top of LEX. So we've got simple goals, and then the fifth thing is probably rounding up and concluding and that sort of thing. I should say that probably coming out of this, there'll be a project, a repository on GitHub, and I've started an organization called Tech Hour for such projects. So I set one up a couple of weeks ago for LaTeX best practice. And all I did there was search Google, make a list of the top 10 results, create an issue for each, and the issue is summarize this page. And it's amazing what you can get from that. So one of the things that comes out of that fairly obviously is some publishers wish to provide information about LaTeX best practice related to their journal. And it's also a place where you can start building a community of practice. So I can contact people, or other people can contact people and say, we're summarizing your page on LaTeX best practice, and we'd like you to help us and participate, or you might be interested in what we produce. So at that point, I'm going to stop. Well, I've said I'm going to stop, and now I'm going to stop.